What's up, guys? Welcome to another video. In this video, we're going to learn how to test Kafka using test containers. Alright, so let me show you what are the dependencies that we require. Okay, first we need in this demo, because this is a Spring Boot web application, so we need this Spring Boot starter web, but this is not required if your application is not a web app. Okay, so since we're going to use Kafka, so we need this Spring Kafka dependency, and also we're going to use JUnit, so we need this Spring Boot starter test dependency. And since we're going to use test containers, so we need also this Spring Boot test containers. Then we need to use our test containers in JUnit, so we need this JUnit-Jupyter. Okay, then last but not the least, we need the Kafka for test containers, this dependency. All right, so let's go to our test class. All right, so we're going to use string boot test annotation and test containers. Okay, please take note, if we're going to use test container, we should have a Docker installed in our local. Okay, I already installed Docker in my local. As you can see, you should be able to run Docker like this in your command in your terminal. Okay, so my Docker is working, so I can use test container. Take note, again, if you don't have a running Docker, you cannot run any test container test cases. All right, so take note of that. That's prerequisite Docker. Okay, so first, for us to be able to test our Kafka, we need to create a Kafka container. All right, so we need to create an instance of Kafka container and pull the Kafka image, the latest version. Okay, using this Docker image name parse. Okay, so after we create the Kafka container object, we can use, so once we already have the Kafka container, we can use the server, the internal server from that object. Okay, and replace the configuration in our application properties. Remember, in our application properties, we have the Kafka configuration, right? Like the server and all details like that. But we're not going to touch the application properties because that configuration is meant for our actual environment, for like UAT or production environment. So we're not going to touch that. Now here in our test class, we are going to override that configuration using Kafka, using the server details from our Kafka container. That's why we created a container, Kafka container here, because we're going to use the server details to replace or override our Kafka configuration. Okay, all right, so yeah, so after we're done with our test container configuration, we can use already our API Kafka template. In this demo, we're going to use Kafka template. This Kafka template allows us to send Kafka message. All right, so it's provided by our Kafka library. All right, so now we're going to verify whether we can send Kafka message using this template. Of course, if our environment, in this case where our environment is provided by test container, if our Kafka environment is working, we will be able to send Kafka message. Otherwise, it will fail. All right, so let me verify this. Excuse me. So here I will send Kafka message using the Kafka template, and will verify whether this message will be received by our client or our Kafka consumer. Okay, I created a simple Kafka consumer here. As you can see here, I have a Kafka consumer. So I use a Kafka listener to listen to this topic. Then once I receive the message, I will simply print it out and save it to my cache. Of course, in the real world, we do not use this, right? We have a JPA or any JDBC API to store the message to our DB. But for simplicity, I just create a simple cache util to save the message. Then later on, I will retrieve this message from the cache. Okay, that's why I have here in. Let me show my simple utility. For testing purpose, I created this. So basically, I will save the message into static, then retrieve it. Okay. Of course, we don't do this in real world. This is just for demonstration, that just to show you that we can that our Kafka consumer is really working. Because yeah, because I don't want to make it complicated. Of course, in real world, we should use JDBC or JPA API to store uh, our messages. Okay, so here after we send the message, we the consumer will consume the message, print it out, then save it to cache. Then in our test, we will verify it using the same util. Okay. So let me run this and verify whether this message will be received by our consumer. How to verify? I have here a this chunk of code. Actually, this await method is a static method provided by our test container. This is normally used for verification. So basically, it will wait and poll it will set the poll interval to 3 seconds, and at most the timeout is 60 seconds, and it will wait until this condition is satisfied. Okay, that's why I have here until assert. All right, so I will the message is, if the message we receive from the cache is equal to this, then it will yeah, it will successfully terminate. All right, so let me run this and verify the output. Okay, our our container is created already. Now Spring Boot is running. Sorry about the background, it's quite noisy. There is construction outside my place. It's taking some time actually. I hope it will not fail. I'm wondering why it's taking some time to execute. Normally it's not that slow. Actually, it is slow at first because it will download the image, the Kafka image, Docker image. But it's once it's downloaded, the second time around you execute your test class, it should be much more faster. Oh, it's failed. Let me run again. Maybe it's timeout. It's timeout, that's why it's failed. Yeah, now see, you can receive it. So it should be okay now. See, so it failed earlier. It failed because I think it's the timeout. It's a container issue. I think it's taking some time. But then again, after rerunning it, we received the consumer received the message. That's why you can see this in the log. Message in group. This one. All right. So our task container is working. Thank you guys for watching this video. Hope you guys enjoy this video. Until next time, have a good one.